Hello, so today we are going to do problems from this week's weekly contest 401. So the first problem is find the child who has the ball after k seconds. So what does that mean? So basically we have two numbers, n and k. What does each one represent? N represents the number of children we have, so we have some children. And k represents the second we want some result at. Now, what is that second? So these children are standing in a queue in order from left to right. Okay, so three children, 1, 2, 3, or if we start from 0, 0, 1, 2, like you have here, and then we have seconds that go, each second passes. We start out with the first child holding a ball, and then they pass it in a direction, either right or left. So first they start passing it to the right direction. The first seconds, child 0 has the ball. Then 1, they pass it to the person to the right or child to the right. Second 2, they pass it to the child to the right. But now you can see we can't pass it anymore to the right, so we reverse direction. Okay? Once the ball reaches the end of the line, we reverse the direction. That goes for this when we reach here and when we reach the beginning. So you can see each of them passes it until we get to the last one. We change direction, we go left. Now in that case, it passes it to 1 and then it passes it to 0, right? Okay, so once it's passed to 0, second 4, now we have to pass it back to we have to reverse again. So we go like this. Okay, so you can see it goes like all the way to the end, then it comes back, all the way to the end, then it comes back. Okay, now what's our goal? Our goal is we have n children, and each second we know what happens. We want to know at second k, right, which child has the ball at that moment, right? So that's what we want to do. So if you take a look at this first example, first child has the ball, then we go here all the way to second 5. It's this one that has the ball, child 1. We start indexing from 0, and so child 1 has the ball. Okay, so that's the idea. Now if you look at this one, n equal to 5, k equal to 6, same thing. We go all the way until 5, 3 passes it to 4 passes it, so we passed it to 4 at second 4, and then we have to reverse direction, so we pass it to 3 and then we pass it to 2. Now the last one that has it is 2, so we return 2. So that's the idea. Now how do we solve this? Okay, so how do we tackle this? Well, a couple of things to notice first. Let's just bring them up here. So the first thing to notice is that what's the length of each round, right? By round I mean we said that we go left and then go right. So if you take the first example here where n is equal to 3 and k equal to 5, you can notice something here. The first round we go 1, 2, we start from 0, so we go it starts at 1. So how many passes we do? We go to 1 and 2, so we do 2 passes. And then we reverse direction. How many passes we do in the reverse direction? Well, 2 passes it to 1, 1 passes it to 0. So again, we do 2, even though n equal to 3. So already we know that each round has n minus 1 passes. Okay, now the other thing, how do we know which direction we are at, right? How do you know if we should, because to know which place, which child has the ball, we need to know which direction we are going in. Because let's say if we have something even bigger, like let's say 1, 2, 3, 4, 5, 6, 7, okay, and let's say we know we already did maybe 3 rounds, okay, and for the current round we are at maybe 3 passes. Okay, how do we know, is this place or is it this place, right? Because if we are at 3 passes, that means it could be, if it's forward, it could be from this to this, then from this to this, then from this to this. Or it could be from this to this, this to this, and this to this, right? In each case, 1, 2, 3. So sorry, 3 actually is like this. So it could be this to this, first pass, second pass, third pass, or it could be first pass, second pass, third pass. Here it happens to be at 4 because it's the middle, but what if we are at 2 passes? If we're at 2 passes, then either if it's forward, then we are at 2. If it's forward, if it's backward, then we are at 5. So depending on which direction we are at, the answer is different. So we need to know which direction we are at. Now we don't care about the complete rounds because those are already done. It's just it will help us know which direction. Now let's see how it can help us know. Let's take if we already completed 0 rounds. So completed 0 rounds, what does that mean? So that means we are at the first round, but it did not complete yet. Okay. Now in that case, we know that the direction is forward because we start out going forward, right? So that basically tells us direction is forward. Now what if we completed 1 round? So this means we are at the second round. Okay, so that means we already went all the way till 2, like in this case. Now we are going back, so that tells us we are in the backward direction. Now if we keep going like this, if we completed like 2 rounds, what does that mean? Well, 2 rounds means we are at the 3rd round, so that means we already went forward, we went backward, and now we are going forward again. Okay, so 2 rounds means forward. Same thing if we are at 3 rounds, that means we are at the 4th round, that means we are going backwards. So you already see here that depending on the parity of the number of completed rounds, we can determine if we are going forward or backward. So let's look at this. If it's even, like in these cases, that means we are going forward. So if number of completed rounds is even, that means current direction is forward, because that means we are at the even round count plus 1, which means going forward. So now if it's number of completed rounds is odd, current direction is going to be backwards. Okay, so at least this will determine for us if we are going forward or backwards. Now, as I said, depending on which direction we are at, we can tell if we should count from the left or count from the right. Okay, so if the direction is forward, that means we need to count from the left. Okay, now if the direction is backwards, that means we need to count from the right. Now what does count from left mean? Well, count from left just means, let's say we completed 2 rounds, and then now the remainder is, if we take, let's say, if we take n divided by n minus 1, of course, because we are working with the passes, then if we take that n minus 1 divided by k, that gives us the number of completed rounds, right? Now, for the current round, to know where we are in the current round, we just need to know the remainder of the division, right? Okay. Now, how can we know if we are going forward? We know the remainder basically means how many passes in the current round. So if we are going forward, we know that we should count from the left, and so it's just going to be the remainder value. Now, if we are going backwards, remember that means we are starting from the end. So to count that is going to be the length of the array, or the number of children, minus the remainder, because we are going from right to left, right? Because let's say, for example, the remainder is 2, but the direction is backwards, right? Then to know the index of the child, it needs to go 1, 2. So to find this value here, we need to do 3, 6, 7, 7 minus 2. to find the index of 5, which is 5 here. Okay, so we have to go right to left. And so this basically, knowing the direction will help us know whether it's this or this. Okay, and that's pretty much it. So what we do is we get the number of rounds to know which direction we are at, and from the direction we can know which one to return. And that's pretty much it. So let's code this up and make sure it passes. So first, since we are going to do n-1 for both the remainder and the number of rounds, let's just do n-1, because we are only interested in the number of passes. Now to know the number of rounds, it's going to be just that n divided by k, or actually maybe let me just let's do it like that. So n divided by k, and then to know the remainder is going to be n modulo k. Alright, we already did n-1, so we do n modulo k. And now to know which directions we are in, right, we can just check if it's even. That means we are going forward. So that means forward, forward direction, which means we are counting from left, which means we can just return the remainder. Otherwise, we are going backwards, so we are counting from right. So this is backward direction. Now in that case, we return n minus the remainder. Okay, so pretty straightforward there. Except here we need to do that, run this, and sorry, this should be k modulo n, and the number of rounds here, sorry, I made a mistake. This should be the number of seconds divided by n-1, right? Because that's what's going to give us the number of rounds. Because let's say if k is smaller, then we'll have 0 rounds, so this makes sense. Same thing here, sorry about that typo. Okay, so we can just adjust this. This needs to be k divided by n. Cool. Now it's intentional here to use n after we subtract 1, because remember, this is the number of passes, right? So it needs to be n-1, and this gets accepted. Now this is of 1 time because we are only using single operations, so it's pretty efficient. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.